Probably.
We are talking about a lot of stuff. It's quite, someone said this is a long section. Yeah, it kind of is. Okay, there's going to be a lot of repetition here. We're looking at graphing techniques. We're going to talk about stretching and shrinking. And I will tell you, I've been teaching this for a long time, and I probably will not use the word shrink. Okay? I call it compressing. But is that effectively the same thing?
No.
Okay. If I had a gummy bear, if I grabbed its head and grabbed its feet and stretched it, it would become skinnier and taller,
No.
right? Until it broke. But if I took the gummy bear, put it between my fingers and pressed on its head and its feet, I would be compressing it. It would become shorter and fatter, right? So we're going to talk about vertical stretching. We're going to talk about vertical compressing. We're going to talk about horizontal stretching. We're going to talk about horizontal compressing. We're going to talk about reflecting. We're going to talk about mirror images, specifically reflecting across the x-axis or the y-axis. Obviously, if you reflect something across the x-axis, it is symmetric about the x-axis. If you reflect it across the y-axis, it is symmetric about the y-axis. We're going to talk about even and odd functions. An even function is symmetric about the y-axis. An odd function is symmetric about the origin. The odd functions are kind of odd. They are symmetric about a point. They're not symmetric about a line. Okay? And a translation is also known as a, I'm listening,
Shit. I don't know.
It moves. Oh, slides.
a slide,
I
okay?
said shift. That's
So a translation is going to be a slide. Good, good, good? We were considering how the graphs of y equals AF of x and y equals f of ax compared to the graph of f of x when a is greater than 0. Everything that we do as far as stretching and compressing, we're talking about a being greater than 0. If it appears that a is negative, we're actually going to ignore that negative sign and use it for something else. Okay? If the a is in front of the function, it's affecting the y value. It's affecting it vertically. So if the a is in front of the function, it's changing the vertical status of the function. If a is, I'll write this out. If a is greater than 0, that's going to give us a vertical stretch. If 0 is less than a, which is less than 1, that's going to be a vertical compression. Okay? What does this mean here? If 0 is less than a, which is less than 1?
A is in
It
between
stops.
1 and 0.
It's between 0 and 1.
okay.
So it's a number, it's a fraction less than 1, right? So if I take half of something, it's going to compress it by a factor of a half. Right? If a is greater than 0, let's change that to greater than. I said this all day and didn't catch it till just now.
Wow.
If a is greater than 1, then it's going to be a vertical stretch. It's because the way the book talks about it right there. What got me off. Okay? What happens if a is 1?
Nothing happens.
Yeah, I mean, it's not going to stretch or compress, right? If you multiply by 1, it doesn't change. So if you multiply by a number less than 1, it compresses. Multiply by a number bigger than 1, it stretches. Vertical is simple to do. Makes perfect sense.
What about negative?
Okay? we take the negative off and just look at the A. Okay, because the negative does something else. We'll talk about that in a little bit.
Oh, I already did this. I'm silly.
The A has moved.
Facts.
Now the A is with the X, which means the A is with the horizontal change. It's going to affect it in the X direction. And I'm going to do two different graphs today. One of them has a horizontal and one of them has a vertical response, and the graphs look identical. And I'll show you those when we get there. Okay? So here, this is a weird thing. When you have a modification to a graph inside of a grouping symbol, like this is inside the parentheses, the change is actually opposite from what you would expect. So, if A is greater than 1, that's going to lead to a horizontal compression. And if 0 is less than A, which is less than 1, that's going to lead to a horizontal stretch. That's exactly backwards from vertical, isn't it? And as we graph these, you'll see what happens. Questions so far? Okay.
Wait, you should
Should what?
go back real quick so I can switch up.
Are you
So-
happy now?
Yes, thank you.
So it's almost the same concept of literally like one is your base starting point and whatever else it is, you're multiplying everything else by it to change the sign.
You're multiplying by that number exactly if it's in the vertical direction, and you're multiplying by the reciprocal of that number when it's a horizontal. We'll get some examples in a minute. And the book does it differently. Okay. We're going to graph g of x is equal to 2 absolute value of x and compare that to the parent function. So since we are comparing that to the parent function, what I would like to do is graph the parent function first. So I'm going to graph the parent function, call it f of x, because that's different from g. And you tell me, what is the parent function?
Oh, the absolute.
That's all there is to it. Yeah. The parent function is absolute value of x. Okay? So my blue graph is going to represent the parent function, which is the absolute value of x. And the absolute value of 0 is 0, absolute value of 1 is 1, absolute value of 2 is 2, and so on and so forth. And if we went in the opposite direction, the absolute value of negative 1 is 1, absolute value of negative 2 is 2, and so on and so forth. So this is the parent function for the absolute value. Y'all good with that? Okay. In red, I will graph the 2 times the absolute value of x using transformations. Is that 2 with the x?
No.
No, it's not with the x. So because this 2 is not with the x, then it has to be with the y, because that's how this thing works. Which means this 2 is going to affect this graph vertically. Okay? Whatever value I get for the function, I will multiply it by 2. So this is a vertical stretch by a factor of 2. Vertical. Does that affect the y values or the x values? It affects the y values, right? Which means the x values are going to be the same. So for example, the point 0, 0. The x value is 0. It's not going to change. The y value is 0. I'm going to multiply that by 2. 0 times 2 is,
0.
okay, so that point didn't move. This next point, the x value of 1 is not going to change because we're doing a vertical stretch. The y value is 1, and that 1 is going to be multiplied by 2. 1 times 2 is,
2.
so the y value here is a 2. The next point, this point is 2, 2. The x value of 2 is not going to change. The y value of 2 is going to be multiplied by 2. So the new y value is,
4.
We did this last semester, didn't we?
yes, we did. Okay. And this is going to be a straight line. Do I need to do the same thing on the left side?
No.
You can just.
Symmetrical.
It's symmetric about the line, about the y-axis. Okay, so we can just draw this. Are y'all good with that? Does that look like I took it and stretched it vertically? Did it get skinnier by stretching it? Yes. Is that good? Can I go on?
Yes,
Just making sure.
thank you.
No problem. We'll start off with the same thing on this problem. I will start off by graphing the parent function, which also happens to be the absolute value of x. Am I changing the value of x or am I changing the value of y?
Y.
I'm changing the value of y because the 1/2 is not with the x. So what does this 1/2 do?
Shrinks it.
Stay vertical.
Vertical.
It's smaller than 1, so is it a stretch?
No.
This is a compression. By a factor
1.5.
of 1/2. So is it going to appear to be fatter?
Yes.
Okay. The 0, 0 is not going to change. I'm jumping all the way to the end. This x value, this point here is 0.1010. The x value of 10 is not going to change. The y value is 10 is going to change. 10 times 1/2
5.
is 5. And reflected. Something like that.
I
Is
think
that-
you're off.
Huh? What? I counted to 5, right? It might be curved a little bit. Those lines are supposed to be straight,
Mhm.
and if they're not straight, it's because your mind is warped. Are you good with that?
Wait. You just multiplied all the y's by 1/2, right?
That's right.
Okay.
Every y value is multiplied by 1/2. The x value stays the exact same spot. Okay, next one. 3, 2, 1, go. Is the value of x being changed?
Yes.
The x value is being changed. The y value is not being changed. This is going to be a horizontal something.
Right.
Okay. Remember, anytime something is inside of a grouping symbol, it's going to be opposite of what it apparently would be. So common sense would tell me this is probably a stretch because of the number 2, but it's inside a grouping symbol. This is going to be a horizontal compression by a factor. Now hold on, compression has to be less than 1.
It would be -2.
It's 1/2. Okay? Folks, this is how I do it. When it's inside and I'm multiplying, I always multiply by the reciprocal. The book says you're going to divide by A. I say we're multiplying by 1/A. Who's right? The book says divide by A. I say multiply by 1/A.
You're saying multiply by 0.5, the other one's saying multiply by 2.
No, they're saying
Same thing.
They're saying divide by 2, and I'm saying multiply by 0.5. And they're the same thing.
Same thing, yeah.
They're exactly the same thing. So if you go through the book stuff and you like thinking through it that way, that's great, do it. Okay? When I'm doing it, I'm going to multiply by the reciprocal. Okay? Have any of y'all even looked at the book at all online?
No.
No.
You know you have full access to the entire textbook online, right? Where it says
Yeah.
view e-text. Did anybody buy the book?
Cool beans.
$20? Okay.
$1 No, you're the teacher. You're supposed to teach me. I don't need a book.
Okay. Horizontal compression factor 1/2. Does the x change?
No.
Horizontal.
Yes.
Horizontal, the x changes. Does the y change?
No.
0.00 is not going to change, is it?
No.
Never.
Okay. This point here is the point 10, 10. The x value is going to change. The x value is going to be multiplied by 1/2. Half of 10 is,
5.
and what's going to happen to the y value of 10?
Stays the same.
Same.
So this point here is actually going to move to here. Again, because the x value was multiplied by 1/2. Does that look like a horizontal compression? Does it look
Yes.
like I took the sides and pushed them in?
Yes, it's like a book.
Wait, doesn't that do the same thing that we did earlier?
Okay, so look at this graph,
Whoa, what is up with the line?
and then look at this graph.
No, same.
Look at this graph,
Wait,
look at this graph,
mine's different.
okay? Other than the fact that I'm not perfect and the lines are a little bit different, how do you feel about these two graphs?
They're both being.
Aren't they the same?
Yeah.
Which is exactly what I was talking about a while ago. This graph is a vertical stretch because the 2 changes it vertically. This graph is a horizontal compression. Effectively did the exact same thing. Okay? But when you're asked what took place to change from the parent function, don't tell me that this is a vertical stretch, because this is not a vertical stretch, this is a horizontal compression. Okay? Questions on this?
Wait, what'd you say about the 1/2 part? You said it's like.
When it's inside the grouping symbol, you're going to take the reciprocal of that, and that's what's happening.
Okay, that's. I don't know.
Other questions? So here's one slide that kind of talks about what we just talked about. We're talking about a vertical change A vertical change is going to affect the y value only. If a is greater than 1, it's a stretch. If a is between 0 and 1, it's a shrink. And here's a couple pictures that show you a couple graphs, one stretched and one is shrunk or compressed, whichever word you want to use. Okay, next slide. One slide talking about horizontal stretching and compressing, just like we did. Except here's what I was talking about. Whatever a is, they do x divided by a, which is what we did too, right? Except I multiplied by the reciprocal. Everything else is the same.
What's a reciprocal?
Do what?
What's a reciprocal?
If I had the fraction 2/3, the reciprocal is 3/2. Reciprocal, you just flip it, right? The number 2 is 2/1. What's the reciprocal of 2/1? 1/2. Any other questions? Okay. Reflecting means forming the mirror image of a graph across a line. The reflections we're going to look at, as far as reflecting across a line, it's going to be reflecting across the x-axis. We'll talk about reflecting across the y-axis. And those will get you mirror images. Next slide. We're going to graph the function g of x equals negative square root of x. So a while ago we talked about a. And everything we talked about, we said that a is positive, a is positive, a is positive, and folks, a is positive. But what if there's a negative sign in front of it? That's not, I mean, it's part of the a, but we're not going to treat it as far as the compressing and stretching go. Okay? We're going to take that negative and say, okay, that negative is a reflection. If the negative is out here, this is not with the x. Because it's not with the x, this reflection is going to reflect it, changing the y value. So if the y was here at 5, it's now going to be at -5. So when the negative sign is in front of the function, this is going to be a reflection across the x-axis. I guess I'll do this one in a different color. The parent function of that one is
Square root of x.
something squared back. And show me what that looks like. What does the graph y equals square root of x look like? I'm seeing some x squares. That's wrong.
Isn't it square?
No, that's.
Oh
Okay.
no, that's actually.
Wait, no, it's
It goes
like,
like this.
it goes, and then it's like a little.
Oh yeah, it goes zoom.
What's the square root of 0?
That makes more sense.
0, 0.
What's the square root of 1?
1.
1.
1. I'm not going to ask some hard questions. What's the square root of 4?
2.
What's the square root of 9?
3.
What's the square root of -5?
I'm out. A cap.
That's it's
Not defined. Right?
And it's the same.
So the parent function looks like this.
So I was right with this game.
Okay? That's what the square root of x looks like. What does negative square root of x look like?
The same thing, except for the
It's right
So
under
you're
it, it's right
gonna
under
put
that
it to the left.
No, it's right
JK.
under the red
This is
one.
the x-axis.
I'm sorry.
It's right under the red one.
Gosh.
Okay?
That like
Third.
reflects.
So that point reflects on top of itself. This point reflects here. This point reflects down here.
No.
Nope.
There you go.
one more. There you
Number 6, right?
Glad it was only 2 to count to. And this point reflects too. I was just seeing if you're paying attention. So it reflected across the x-axis. It looks something like that.
No, I just have like a little air horn in my bag. I do.
Okay?
You never know. Wait, that was
Now what happens?
Oh, wait, it's gonna go like.
Now it's gonna
The
go from
Y.
left to right across the Y
Okay.
axis.
What is the negative sign with?
X.
It's with
It's
X.
with the X. It's going to change the X value. So if I have an X value here, it's gonna change that X value from a positive 10 to negative 10. So this is reflecting across.
Y axis.
We'll start off by graphing f of x, which is the square root of x. And where's it going to be if we reflect it across the y-axis? That point reflected to nowhere. 1 away. 4 away. 9 away. And it looks like a patriotic bird.
I'm missing the white.
The graph is
all
like,
white.
The lot.
sit down. We good? Okay.
Mine's black.
So obviously if the negative's in front, the y value changes. If the negative's with the x value changes. Pretty simple stuff there. And we'll start on this slide. Maybe tomorrow. Maybe Tuesday. Depends on how things work out for us.
Ooh, a 4-day weekend?
This is
Don't
Rory.
I'm
You do
gonna
my
pray
Valentine's?
to Jesus and say that I'm
That's a definite no.
go to church Sunday.
What if I get you like one of those gigantic teddy bears?
And he should know that. If you don't know, he knows that. I have a question, sir. I was looking at this thing tonight.
Okay.
How do you see, I was looking at this too, and then I looked at the Greek one to see like what classes are in it. But then I
I read this has so much more grade.
it does not say like for associates or for like a bachelor or anything. Nothing.
All of
I'm scared too. Because this, it doesn't tell me any of my things except like only called like technical graph, solid model design. I don't know what that means.
Do you think it's gonna be like slippery?
Oh, I'm sure.
Oh yeah, tomorrow's probably gonna be really dangerous to the weather.
I mean, the temperature's been below, it's freezing now, so I guess that's a plus.
Wait,
It was funny.
Wait,
Did
wait.
he not say unless it was below 30 and it was like 29 when he said that?
It's up to 32 now.
This morning it was at 30 and.
I slept in as late as I could, hoping to learn some things.
I noticed one day that we were supposed to be the high 19 and low 2.
No, it's worse than that.
It's supposed to be 7.
Well, it's less than so long.
So like, why did we come to school
Yeah,
today?
18 2.
Oh, earlier today was 15 and 0.
Really?
Yeah,
For what, tomorrow?
Monday.
Monday.
I'm going to
Okay, but
enjoy
why are we
my
If it starts snowing, I'm gonna go.
everywhere.
Yeah, there's icicles all over the banisters.
And I never get the first have enough to go home.
No, because now imagine what the roads are like.
Exactly why we need to go.
I'm sorry, but my bus driver is a little cuckoo. I'm not getting on that bus. I trust Andrew Williams' stupid driving because at least that I can control.
I gave Rick my car, so now I can't really, if they say like.
All I'm saying is Tokyo Drift is my favorite movie.
No,
Bye all. Be safe. Someone left their backpack.
Like that song is stuck in my head, and it's playing on repeat.
This is recording.
What you got, bud?
Yeah, bud, get some water.
Yeah.
You know. Right, it's $1 for 2.
You getting 2 of them?
Yeah.
Go ahead, bud.
Your mine, the mine's on your.
I got mine.
Perfect. Make sure the refrigerator's closed.
Alright.
Thank you, sir.
Traigo hasta el culo de agua.
Oiga.
No,
Why?
qué pedo.
We should have more underneath the sustain.
Oh, bad. Well, it's actually not going here today, actually. But if I get cold, I'll probably drive
Era
later.
un pedo porque tengo que ir.
Alright.
Sabía